It's like a date competition. All of a sudden it's a script. Have you?
All right. Good evening, everyone. And welcome to the last meetup for this year. I feel like actually we've been pretty successful. I want to say this year we've had 7 or 8 meetups, which I think, given some of the instabilities we've had in the past few years, especially since coming back in person, we've had most of the month this year. I know there's been 1 or 2 months we haven't had them, but I think we actually got a pretty good run in this year. So thank you for everyone for your continued attendance and helping keep this meetup group going. Those who don't know, in the dev community group, I think we are actually the most active meetup group of all of them. And we're starting to catch up to us now that I got some collaboration in New York, but I think we've been keeping it going. So let's keep that momentum going. Let's try to keeping the most active meetup group next year. So welcome. Hope everyone had a good Thanksgiving and is enjoying some time off, enjoyed some time off and is, kind of enjoying that nice December lull before we go into the holidays. So without further ado, I will hand it over to our speaker tonight, Danny.
Share a thing.
Usage of UIKit. That's what I want. Yeah, nice.
How's it going? So just a quick poll. If you could just hold 1 to 5 fingers, how do you feel about your experience level with SwiftUI? 5 being like an expert, 1 being you haven't used it yet. Okay. How about combine? Same thing. Okay, cool. There'll be a little bit of, a lot of SwiftUI in this talk, just a little bit of combine. So, just some goals for today. So SwiftUI has been out for, I guess, 5 or 6 years now, since 2019. So every year there's more and more components that are available for SwiftUI. But there's still a lot of components that are only available in UIKit. And you probably have also in your projects a lot of UIKit only code. And wouldn't it be nice to be able to wrap that up in a single component with a SwiftUI API and be able to reuse that? Especially if you have a new app and you want to reuse that in a completely new app and just plop it in there. SwiftUI is really great for that because of its declarative nature. So I'm hoping to, at the end of this, you have kind of like a blueprint for if you wanted to build your own SwiftUI wrappers, kind of like how you see that Apple builds, that you will feel empowered to be able to do that. So we will talk about a couple different SwiftUI design patterns and how to implement them. One of the ways, the way I ended up doing it myself, and also the why. So like, what is the journey that led me to need to learn about all this stuff? So first, a little bit about me. Hi, my name's Danny. I am an iOS engineer. I was previously working at Rocket Mortgage as a senior iOS engineer, and now I'm just building my own apps. My main app is an app called Tutti. It's the sheet music reader for musicians. And when I'm not working on that, I'm playing in orchestras and I'm hanging out with my dog, Charlie, who really loves treats and cookies. So a little bit about my app Tutti. So it's a sheet music reader that allows musicians to organize all of their music into their iPad in folders and set lists. You can annotate your music with a couple different tools and just draw right over it. And I use PencilKit for that. There's also some metronome and tuner tools and different tools like that that can overlay on top of the music. And at the core of 2D is a PDF viewer, really. It's a PDF viewer with a bunch of tools on top. So this is a really important part of my app. And this is how I originally architected it. And so at the top, you have a sheet reader view, which is in SwiftUI, which basically enables and holds onto the state through a bunch of view models as well, for a lot of different functionality. And then the sheet reader view contains a sheet stack. And the sheet stack has each track of 3 views on the screen at a single time. So you have the view that the user is currently looking at, then you have the sheet that's the next page, then you have the sheet that's the previous page. And I'm using SwiftUI gestures and offsets to be able to animate through that as you're turning the page gradually. Then there's a UIKit component within each sheet view. And that UI component is a view controller that layers a UI image of whatever image corresponds to that sheet in the music. And then there is a PK canvas view that allows people to draw on top of each image. And PK canvas view is a part of PencilKit from Apple. And it allows you to, draw with Apple Pencil or draw with your finger, stuff like that. The sheet reader view also pre-warms various images as needed and then stores that in a cache as well. So as the app has grown in complexity over time, I've started to realize I need to build a new reader because there's a lot of limitations that I'm starting to get up against here. So a few limitations here. For one, the annotations that you draw on top of each page, they don't really scale very well. And especially now with iPads, it's getting a lot of features that Mac has, like being able, with Stage Manager, you can change the size of the screen of the app that you're currently looking at. And then with the full resizability that you get now with iPadOS 26, Apple's actually deprecated this keyless property called UI requires full screen. And I was, before 26, requiring the app to be in full screen, but because of some of these limitations, I did find a kind of a hacky way around it using a scroll view, but it's not really gonna last because I'm realizing that I need a much better architected solution. Another limitation is that SwiftUI gestures, they kind of don't really work well with system gestures sometimes. And every year I've noticed that Apple very slightly changes how SwiftUI gestures work under the hood. And that ends up causing conflicts when you have to make sure that the SwiftUI gestures don't conflict with system gestures. The main system gesture that I have to deal with is when you swipe to the edge of the iPad, the library comes out from the side. And so that system gesture a lot of times was not working well with my page turning SwiftUI gestures. And also, as you're turning pages, it's rendering new images and putting them onto display, which is very expensive for the main thread. And being able to do that while performing SwiftUI gesture animations, it's very easy to get hitches, which are like dropped frames. And you always are going to get a little bit of hitches doing something like this, but it's very easy to make it so that without, paying close attention, it can start to be a thing where like get really high hitches that the user starts to notice. And I need a solution that's a little bit more performant in that way. Furthermore, there's a lot of features that I want to add in the future, like being able to sync data through iCloud, having an iPhone version, text annotations, music stamps, half page turns, and turn pages in annotation mode, which is another feature request I get a lot. So I built a new viewer for Qt. I had a couple of high-level requirements for this. For one, the annotations on the page should scale really well if the user changes the viewport size. Secondly, I wanted to build this entire component in UIKit for maximum flexibility and performance. And I also wanted to put it in its own package so I could potentially reuse it in another part of the app, or if I wanted to reuse it in a completely new app, for example, I could think of another app that would need a PDF viewer, and I could just really easily plop it into that new app. In order to do this, I also needed to build a lightweight SwiftUI API to plug into this existing SwiftUI code base. And of course, it needs to be able to support whatever I build needs to support the future roadmap. So I had a couple different options that I was considering when I was trying to figure out how to build this new viewer. Option number one was to utilize something called PDF View, which is available as part of PDF-Kit from Apple. PDF-Kit does a lot of things with PDFs, but the PDF View component, which is a UI view, actually renders the PDFs onto the screen and has a lot of really nice features. And I started prototyping with this, and I was building out features so quickly, and I'm like, oh, this is going to be great. But unfortunately, it didn't really fit my future roadmap very well. It just wasn't as flexible as I needed it to be, which I was really bummed out about. So fortunately, I had to reject this idea. Second option I had was maybe I'll use a third-party SDK, something like PDF-Kit. And it had everything I needed, so that was also really exciting. But I ended up deciding that I didn't want to be economically dependent on another SDK, especially for something so core to my app. So I had to reject that idea. But of course, there is always a third option, which is let's build it from scratch. Why not, right? Fortunately for me, I had a couple streams of wind at my sails. For one, I could still utilize PDF-Kit for its utility classes. It does render really easily a PDF page to UI images, and I could utilize all of their object models, PDF document, PDF page, PDF annotation. All of these are modeled for me, and I can just concentrate on building the viewer using these models. Second, I started building this new component, new viewer, when Codex came out with GPT-5. And this really helped me, especially since I put everything in its own package. Because I made this component its own package, it really helped with the context window. So if you haven't used Codex yet, it looks at your entire code base. Now, if I had it look at my entire app, the context window would go really quickly because it's just so much code to look at. Since I was able to put it in its own package, it just was skimming off the context window. And I think I went a week without depleting the context window. It was awesome. And of course, I knew I wanted to build a SwiftUI API or main view controller of my UIKit code. So introducing, drumroll, Super PDF Viewer. So yes, I made an image in ChatGPT for my package. And I'm, of course, a big fan of a certain fighting game. Okay, so what is Super PDF Viewer? So like I said, it's a standalone package built using UIKit, PDF-Kit utility classes with a SwiftUI API wrapper written on top of it. So I like to, for the rest of the talk, mostly kind of go through how I built various parts of the SwiftUI API. So first, I wanted to create an out-of-the-box PDF viewer by only passing in a PDF document. So I want to have one line of SwiftUI code. If you put that into your project, you'll have a fully functioning PDF viewer that you can swipe through and resize windows and stuff like that. And we'll just read through the entire document. So this is the line of code. Super PDF viewer, passing in a PDF document. From that, I just want a fully functioning PDF viewer. So how do you build this and connect it to my UIKit controller that I built? Whenever you adapt a SwiftUI component to UIKit, you want to use the representable protocols from Apple. So there's two main ones for iOS. The one I use is called UI View Controller Representable because I'm going to wrap a UI View controller. But there's also something called a UI View Representable when you want to wrap a UI view. They have the same required and optional functions. They're practically the same, except one is for doing a controller, one is for just a view. And so to get that code I was showing the last slide working, I basically initialized the document that was passing in. And then, so there's two required functions with a representable. The first required function is make UI view controller. This is going to run when your view first loads. So it's only going to run once when it first loads. Or if SwiftUI sees that it's a completely different identity, then it will reload because it will see it as a completely new view. But for the most part, this will run once, and it's going to ask for what view controller is going to be your root view controller that you want to control. So the root view controller is Super PDF view controller. We're going to pass in the document that we're getting from SwiftUI, and we're going to start at the first page, page 1, or index 0. The second required protocol function in a representable is going to be update UI view controller. This is going to get called whenever any SwiftUI state involving this view changes. Remember when I was first learning this, I was really unsure of when this is going to get called. So whenever, and you'll see this in a little bit, whenever any SwiftUI state changes, it will be called. And the point of that is it's giving you an opportunity to update your view controller when that SwiftUI state changes. So with that one line of code, you can swipe through pages. You can resize the window, and the reader will kind of like adapt. So now I can scroll up and down. And if I change the window size again, you'll see it adapts. So now I have a secondary background so you can see where the edges of the PDF are. So looks like we have a visitor. My friend Charlie is saying something here. That's cool, Dad, but how do you control the viewer from SwiftUI? I was right about to get to that. So next we're going to look at how you update the reader appearance from SwiftUI state. But you really could think about this as if I want to update any state in SwiftUI and have it affect my view controller, how do I do that? So we're going to add some state. We're going to create an enum viewer appearance. It has day, sepia, or night. So I can make the viewer look like just what you saw just now, a white background with black text, or it could be like kind of a sepia yellow tint or an inverted tick. Next, we can just start appending functions off the end of this main view, as you do in SwiftUI. But how do you make a function like this? And how do you pass this appearance down into the view controller? How do you do that? So the main way that I do it is I utilize something in SwiftUI called an environment value. And basically what an environment value is these are values that are available anywhere in the view hierarchy. If you didn't intentionally inject it into a part of your code, then it will just give you the default value when you pull it out of the environment. There's a couple environments that you may have heard of. Color scheme, it tells you if you're in dark mode or light mode. Horizontal size width, it tells you if your app is in a compact mode or in regular width. Apple gives you a lot of environment values But in this case, I'm adding my own custom environment value, and I'm adding it into that dictionary. In iOS 7, SwiftUI, sorry, iOS 17, forgetting which version we're on, there was a new macro called entry, and that allows that makes it super easy to be able to add your own custom environment values. You can still do it in 16 and below, but it's just a little bit more code. So I'm creating my own custom environment value called viewer appearance, and I'm giving it a default of day, which is a good default to have. And then to create that function that we saw, that we were just kind of appending it to the last slide, we're going to, in that function, we're basically going to inject that environment value, that state, into our view hierarchy. With self.environment, we're going to inject that viewer appearance into the view hierarchy. And we're going to do that because we want our representable to be able to pull that back out of the environment and then utilize that in the controller. So let's see, it's now in the environment, this property. I'm going to change the reader appearance. You can see SwiftUI knows about it. It's updating in SwiftUI, the toolbar and the scrubber, but the reader itself isn't yet updating. So what do we have to do? So we'll go back into this representable, and we're going to update the make UI view controller function. We're going to pull that viewer appearance out of the environment that we just had put into it before. And a really awesome way to get that from the environment is to utilize context, which Apple provides to you in both make and update UI view controller. Context has a few other really nice conveniences. That's one of them. And we're going to pass that into the initializer for our view controller. And that will make it so that if it starts out in sepia, for example, it will create the sepia. But what if somebody toggles to a different appearance from SwiftUI? We need to make sure that we pull that out of the environment in update UI view controller, and then we apply it to our view controller using this public function update appearance. And again, update UI view controller is going to be called whenever any SwiftUI state changes, including environment values. So that's really nice. So now, if I change that, we'll see that the entire reader now updates to sepia inverted. And I can control that from SwiftUI. Oh, there's Charlie again. Fun stuff. Can I have a pup cup now? That's one of his favorite treats. Not yet, Charlie. So next, I wanted to show you how to keep track of the current page. So in this app, we have a scrubber where you can scrub to different pages. That's in SwiftUI. And you can see I'm going to different parts of the document, but the reader isn't updating. But then I can also swipe to different pages in the viewer, but now the scrubber isn't updating. So what we need is to make sure that there's a unified state for the page index. How do we do that? So a really great tool to be able to have this kind of universal state is to utilize something in SwiftUI called a binding. A binding is a two-way data connection. So the view that creates the state, the owner of that state, can change that state, but also the subview that receives that state can also change it. So you have kind of, you can change it in the parent view, and the subviews know about that change, and then the subviews can change it, and it goes back up to the parent view. So we're going to add that as another parameter in our viewer. And so we're going to actually add that as an optional binding. Why do we make it optional? When you're thinking about an API, you have to understand that, like, hey, the consumer of this API may not want to track the page index. So we're not going to force them to pass in a page index, so we'll make it optional. And then we're going to initialize that, and then we're going to use that in both the make UI view controller and the update view controller. So in make, we're going to access that wrap value and put that into the start index. And if they don't put that in, we'll just have it be at page 1. And then if you change the page with the scrubber in SwiftUI, we want to make sure that the view controller gets that message. And so in update UI view controller, we're going to update the index using that public function from the root view controller. Oh, I used the laser pointer by accident. So that makes it so that we have one-way connection fulfilled. If SwiftUI changes the page index, the reader will change the page. Now we need to go back up to SwiftUI. So if the reader changes the page, then we want to make sure that SwiftUI updates the scrubber. So how do we do that? So there's a third optional function in the representable protocol called make coordinator. And what is a coordinator? A coordinator is a reference type that you can create and have access to throughout the life cycle of your representable. And we're just going to pass self when we create it. So this make coordinator, that's this optional function that we have access to, and we can just pass self, which gives the coordinator access to all the super PDF viewer state. Then we're going to utilize a delegate on the view controller called super PDF view controller delegate. And the reason why I'm going to do this is because we want to make sure that if the view controller changes its page index, we can hook into that point in time. And then once that happens, we can access the parent state and update our page index. So that fulfills the request of going from subview to superview. And don't forget, when you do something like this, set the delegate in to the context.coordinator in the make UI view controller. So this is another really nice thing about the context, is that you can access your coordinator from the context. So now that that's implemented, I change the page index in the scrubber, the reader updates. Or if I swipe on the reader, the scrubber updates. Awesome. There's Charlie again. I am once again asking for a grande pup cup. Yeah, I'm gonna get to that. Just a couple more things here. So another requirement that I wanted to do for this API is so one of the things you can do with a PDF viewer is you can overlay content on top of a page. Like you can draw on top of a page, or you may want to display some text on top of the page or a stamp or something like that. So any of that stuff, or you may want to highlight a certain part. Anytime you do that, that's considered an overlay. And so I wanted to create a way that SwiftUI could provide the overlay to UIKit. That way, the UIKit component could not care what the overlay is. It doesn't have to be a PencilKit PK Canvas view. It can be really whatever the consumer of the API provides. It's basically just a UI view. So here is a function for that. It's called overlay for page. And basically, whenever the view controller requests the overlay for a certain page, basically when it loads up the page, it's going to call this function if it exists in SwiftUI, and allows me as the consumer of this SwiftUI API to just declare it. I'll receive the page that's about to load in, and I can just create a PK Canvas view that the user can just draw on top of. And really, you could put any UI view in here, and it'll just overlay it on the page. So how do I build this? So it's going to be something very similar to how we change the environment, the reader appearance. We're basically utilizing environment values again. Except this time, the environment value is a closure that takes a PDF page and returns an optional UI view. And we're going to create a type alias so that it's easy to remember. And then just like when we were changing the viewer appearance, we're going to create a custom environment value so that we can transmit this closure to UIKit. And by default, it will just return a nil UI view. And in that case, it just won't overlay anything on the page. And then just like in the viewer appearance, we're just going to create a helper function that will inject our closure into the environment. Great. Now that that's done, back to the representable so that we can actually put this into the viewer itself. So in the representable now, we're going to grab that closure out of the environment. And then when we make our coordinator, which is our reference type, we're going to just pass that into the coordinator. And the reason for that is because we're actually going to hook into another delegate function. This one is called super PF view controller did overlay view for page. So when the view controller calls this delegate function, we're just going to call our SwiftUI closure, and that will enable that connection between SwiftUI and UIKit. So now I can draw on the page. Anytime a page loads, it just creates whatever view, overlay view I want. Now I can completely control that part in SwiftUI. And if I change the dimensions of the viewport, it will just scale that annotation really nicely. So this is for, transmitting a closure to UIKit. It doesn't have to be, for a canvas. There's a lot of different use cases of being able to use this when you're creating your own SwiftUI API. How many more of these are there? PubCup incoming? Yeah, I know this is a very code-heavy presentation. There's one more that I really wanted to show you. How do you issue commands from SwiftUI? SwiftUI is a very state-driven framework. So it basically redraws views when state changes, or it causes side effects to occur like on change or task when state changes. But what if I just wanted to issue a command like next or previous? How do I issue that command and just send that command to UIKit? So like in 2D, if I tap on the edges of the screen, it will go to the next page or the previous page. But sometimes I don't want to necessarily go to the next page. If the viewport has a smaller height, I actually just want to scroll to the next part. So you can see I'm tapping on different parts, going to the next or previous page. And now when I tap on the sides, it actually is just scrolling to the next section of the music. And so really, the SwiftUI API that I'm building, it shouldn't have to know, oh, do I switch the page now or do I scroll? I should just be able to send a command, previous or next, and then UIKit should be able to know what to do. So I was trying to figure out how to build whatever API or build something for this to be able to do this. And I was kind of looking at a few different view containers that Apple built, like Geometry Reader, which provides subviews with geometry information, Canvas, and Scroll View Reader, which really caught my eye. Because Scroll View Reader provides its subviews with something called the Scroll View Proxy. And it kind of does exactly what I want to do, which is to scroll to a certain part. I just want to issue a command, scroll to the bottom, scroll to the top. So this is how I did it. So it's kind of like Scroll View Reader. It wraps all of the views. It provides all of its subviews with this proxy. And then I can just say, when somebody taps a button in the SwiftUI, I can tell the view controller go forward or go backward. So how do you build this? So first we're going to create a container view, which if you've ever created a container view in SwiftUI, it kind of looks like this. You have this generic called content, which is restricted to be some view. And then you create this view builder function trailing closure that provides subviews with your proxy. And then we're going to inject that same proxy into our environment so that UIKit can later use it, or so that the representable can use it. So let's take a deeper look at what the proxy is. So of course, it does have that forward and back function, which are just, with command forward and backward. But I'm actually using combine here because I want to basically create this event stream. So when somebody presses forward or backward, I want to basically create an event that my representable will then be able to catch and do actions on. Another important thing, this is an observable object, but I don't have any published properties. But the reason why it is an observable object and I'm adding this as a state object is because I want it to outlive the entire life cycle of this view. So whenever you want to do that and have it just not disappear as soon as the view redraws, you can just install it as a state object and the value will stay there. So how do we make sure that we can get that stream of events and act upon it in UIKit? So whenever you do that, you want to have something called a cancelable and combine. We're going to add that to the coordinator, which is our reference type, which is a really great place to put it since it's a reference type. And then within our make UI view controller, which just runs once when the view is created, we're going to access that event stream, and then we're just going to call view controller forward or view controller backward. Great, so those are the five main examples I wanted to show y'all today. Here's a few other things that I didn't have time to show, but it's basically the very similar concept. Basically creating hooks in SwiftUI so that you know when did the user start zooming into a page, when did they stop zooming into a page, and then some other environment values that I'm transmitting through, like how fast the page should turn, how many pages should the user have up at one time, stuff like that. And the puppy finally gets his pup cup. But there is one more thing. I know this was a super code-heavy talk, which I was a little concerned about. So I wanted everybody to be able to go home with something so that you don't just forget about this. If you want to see a couple examples of how I built this kind of thing, so Super PDF Viewer is closed source, although I could be convinced to open source it at some point. But I did create a wrapper for PDFKit's PDF view with very similar concepts and techniques. So if you wanted to take a look at that, that's on GitHub, it's open source. Thank you very much. Here are my socials.
Okay, I know we have one question in the chat to start, then we'll see if others come in. Sean asks, for the overlay view, how do you manage its lifetime? Is it tied to the coordinator? And then for the overlay view, how do you save or persist it?
Yes, so overlay views, I didn't show that part, yes. So basically in 2D, what I'm doing is I have a state object called, right now I have it in basically the toolbar observable object. And basically what I do is in that hook, that SwiftUI hook. Whenever that gets run, I add that, I basically fire off a function in this observable object. And that will actually put that, that will put that canvas view or that overlay view in like a hash map or something that I can basically hold on to it. And then there's another hook that I didn't show because there's a limited amount of time, but there's another hook called, it's basically saying that it will release that. So basically when you keep swiping and it's no longer in the view hierarchy of UIKit, it will actually send another command, another hook into SwiftUI saying, hey, you can let go of this canvas view now. You don't need to hold on to it anymore. So that's how I'm doing that.
Any other questions?
Yeah, one of the things you mentioned with your app was trying to reduce hitches. And I think one of the cool things that Apple's recently released is the SwiftUI performance instrument
Yes.
for iOS 26. I was wondering if you played with that at all and if that kind of like factored into the process of designing this.
Yes, I'm heavily using the instruments. And recently, I don't know if they like updated it, so it's like much faster now. But when lately it's just been way faster, which has been just so great. But yeah, I've been using it a lot. Basically what I'll do is I'll swipe like 10 times to the right, 10 times to the left, do that 5 times. That will be a run, and then I'll create another run and another run. So I actually recently had an issue where there's like these page turner pedals where you can go to the next or previous page. And for some reason, that Bluetooth connection or something about that creates more hitches for the page turning. And so I was like trying to like diagnose that, but like little things like that, like really affect the performance. It can go like little things like that can make it so that the hitches are not noticeable to the hitches are very noticeable.
Nice. Yeah, one of the things I noticed about it with 26 is you can actually with SwiftUI see like which state change and how that triggered a redraw. And then you can record exactly how many times each view is redrawing, which is really nice.
Okay, I'll talk to you after about that because I'd love to see that actually. That sounds awesome.
Any other questions?
Yeah, so not really to SwiftUI, but for your annotations, are you recording them as PDF annotations in like the PDF tree, or is it like a bitmap context that you're just drawing on, or like how do you do that?
Yeah, so right now I'm storing it. The PK canvas view, it has a function, or PK drawing, I think it has a function that basically allows us to change it to like binary data. And so when I save it in core data, and then basically, I don't have this feature yet, but basically what I'm going to do is if you want to export the PDF, that's when I would actually translate the PK strokes and the PK drawing to annotations, PDF annotations.
Okay, so there's like the pencil kit provides some kind of overlay view that has the actual.
Yes, it does. Yeah.
Any other questions? Anyone?
Yeah, one here.
I noticed that your simulator was on, or maybe your device was on 18. Is there anything that you've noticed that would be completely different with 26 perhaps?
Oh, my iPad was?
Yeah, I think so.
No, I think it was 26.
Was it 26?
Yeah.
Okay, I was looking at the icons. I was in the
But
background.
things are very different.
They are very different, right?
They are very different, yeah.
Yeah.
Yeah, that's been,
Yeah, I was
like,
like,
that could be a whole nother talk is
I agree.
is going to liquid glass.
Thank you so much.
Yeah.
Another question in the chat. Yeah, I may have missed this, but with the Night Sepia, how does the sheet music change its look if it is just a PDF?
How does the PDF change its look?
Yeah.
Yeah, so there's an option to do this basically when you're rendering the image from the PDF page. there's an option to be able to do this in core graphics. I don't remember the exact code because I just basically figured out how to do it and just added it to the app. But yes, there is a way to do it in core graphics when you're actually in the process of changing it. But basically, I am reloading, I'm re-rendering that page as soon as that's requested. So basically, if you change the appearance, it will look at the PDF data again and then re-render it into an image, but in the correct appearance.
Okay, any other last questions? I mean, we still have plenty of time for more, but any other questions? All right. All right, thank you, Dan. Before we stop sharing, go back to your new, like, your requested features slide. Yeah, yeah. Go away. Go back in time.
Itches in this.
As a rock band.
Oh, I passed it.
Yep. Let's see all those, see all the
There we
animation.
go.
Hi. So as we wrap up, I'll just say I'm actually a proud user of Danny's app, and that half page turns on that bottom corner. That's actually my request. Yes. All right, but go with it, yes. All right, but thank you, Danny.
Thanks.
All right, and as we wrap up for the year. All right, time for my usual wrap-up spiel. Especially as we end 2025, if you're interested in speaking for next year, please fill out the form. Again, I can send it out, and as a reminder that obviously while we're starting to do more and more in person, we are a fully hybrid meetup, so you do not have to be in the DC area or come to DC to present. You can still present over Zoom. So if you have any interest in presenting, fill out the form. It is linked on our Meetup page. You can also message me on LinkedIn, on social media, or on any Slack or LinkedIn, and I will get it to you. Subscribe to our YouTube channel. I said now that I have that, gotten that process all fixed up, we will have those videos up on YouTube again. So be on the lookout. I know I just got October's meetup up there the other week. And follow us on our LinkedIn page because that's why I'm doing most of our socials now. I just don't have enough power in my own day to manage multiple accounts. And then finally, again, if you're interested, I have stickers for you for your laptop. And with that, next year, so we are going to take January off, just with the timing of when Christmas and New Year fall this year, as well as a certain event that I know some people in this room attend at the beginning of January. The second week of January would be really hard for me to do a meetup. So we are going to take a break in January. We will come back in February. It also kind of works out because at the moment my speaker queue is actually empty. So if you're interested in talking, you'll get to the front of the queue right away and you still have about 2 months to write up a talk. So if you are interested, please let me know. And with that, thank you everyone. Let's got some time to enjoy yourself, enjoy your holidays, enjoy the rest of 2025, and we will see you all next year.